Hi, Dr. Adair.
Hello.
So today I thought I asked you some questions and just wondering if you could tell us a little bit about yourself.
Absolutely.
Okay, so tell me about your professional background.
I am a PhD from Ohio State. I earned that in physics, focusing on physics education. I also have a background in research and publication on history, religious studies, science and religion, and also pop culture and science.
Right. So tell me, how do you integrate, before we jump ahead, but how do you have so many diverse background in physics education and also, um,
Well, I have been interested in so many things for a very long time and just trying to absorb it and see the biggest picture I can. Physics is so much already about trying to have a picture about the entirety of reality. And if you can't incorporate that also into real life and culture, then kind of what's the point? And of course, also, I want to be evangelical about what I've learned, so education is a big part of that too. It kind of all naturally falls together. I've also had a long interest in history, especially when it comes to like the ancient classical world. The myths and stories of that period has just always been interesting and fascinating to me. So it just was pretty easy to find ways of integrating them all in. And I was actually surprised I found ways of integrating that even into my PhD research.
okay. When you say evangelical about your studies, what do you mean by that?
When I discover something new and interesting and that I think I can verify and show to be true, I want everyone else to know because I think this is amazing and cool. And if you know it, it will change how you view the world and maybe how you picture yourself in the grand picture of things. If that isn't worth being evangelical about, what is?
Okay. So tell me what your research has been about for the past few years from your dissertation, and I know you've written a book, you published a book, and you're currently working on a book project.
Just starting with my PhD thesis work, that was primarily on the fact that we come in with intuitions about how the world works, physical intuitions about force and motion in particular. And the thing is, those intuitions look a lot like the old models of mechanics from ancient Greek times or the medieval period, and they're wrong. They're contrary to even Newtonian physics, let alone anything more advanced than that, and they get in the way of properly understanding the world. So a lot of my research was showing how natural these intuitions are and what sorts of things can we do to better educate people so they actually better do know Newtonian mechanics and classical mechanics, and that way it's not interfering with both learning how to do physics in a physics class, but also fundamentally knowing how the world works.
And when you say intuition, what do you mean by that?
Just with just gut reaction, what happens when this happens? How are these two things affected? So, in particular with force, the intuition we have is that if a body is moving, there must be some force pushing it along. And that intuition is fundamentally flawed because one of the consequences should be is, hey, I don't feel this gigantic force acting on me and the entire planet as the Earth zips around the sun at thousands of miles per hour. So frankly, that intuition would prevent people actually believing in the Copernican revolution.
And when you talk about this force, how do you apply that to, say, an educational theory? Specifically, I'm talking about in a classroom setting, how students learn.
The way I've been trying to do it, and I'm researching to see if it's an effective way, is by showing them, hey, what you believe is what was believed in older times that you now think is ridiculous, that the Earth is stationary and the sun goes around the Earth. You don't believe that anymore. But why do you have this physics intuition that says that's exactly what must be happening? So the fact that I can use historical narrative, whether it's like the big ideas about force and motion, or the particular actors such as Galileo and Newton and figures like that, to tell a story, I'm trying to integrate that more and more into my education methods and philosophy and try to make a more cohesive whole.
Okay. Speaking of philosophy, tell me specifically about your first book project.
All right, the biggest book project I've had so far that's been my own creation has been looking into the various ways that scientists over the last nearly 200 years have wanted to explain the Star of Bethlehem story from the Gospel of Matthew in the Holy Bible. the story about this star that was supposed to interest wise men from Persia or Babylonia to come all the way to Jerusalem saying, hey, we want to come and worship the King of the Jews, the Messiah figure, and then get ultimately led to a particular house. For a long time, people were quite happy to say that was a miracle story. In the early 19th century, that started changing because people were doubting miracles in general, or that God would want to perform miracles somehow made him less. But that becomes a problem when you got a book full of miracles, and so you have all these attempts to explain the miracles away with straight up science and make it totally natural. While most of biblical studies has thrown this out, it's still a very common thing among astronomers and planetarium show workers, things like that. And it drew me in when I first worked at a planetarium and I saw this thing for the first time, a theory for what the Star of Bethlehem was. I was like, wow, that's amazing. It fits my own personal theology. I thought it was great. I go home, there's a TV special on, it's about the same subject. Ooh, I watch. Hey, that theory's different. Oh, there's another one. There's another one. There's another. Okay, they can't all be right. And then I need to explore how do we actually argue if any of them are right, and why is it that this isn't the mainstream view in biblical studies? That was the subject of my book, The Star of Bethlehem, A Skeptical View. Before that book, I'd also published an article in the journal Zygon, the Journal of Science and Religion, about these centuries of interpretation and basically what it can tell us about the interactions between science and religion.
Great. Now, just wanted to talk a little bit more about the interaction of science and religion. Tell me a little bit about your second book project.
Well, that is an ongoing thing where I'm trying to look at the very nature of religious and scientific knowledge. When we discuss the interactions between science and religion, that can be kind of hazy because when we talk about science, are we talking about the practice of science, the body of knowledge, the scientific method, the virtues that make someone a scientist or a good scientist? And do those have anything to do with religion, which itself is a very wishy-washy subject in some ways. There's a lot of scholarship saying that the terminology is a recent historical invention and meaning. So I want to zero in on really where the conflict lies, and it's about claims about what's real, about what's true. And fundamentally, how does scientific knowledge work? How does religious knowledge work? How do they often interact? And what do we do if and when they seem to be in conflict? How able are we to reinterpret revelatory knowledge or texts of religious importance? And does it even make sense to speak about religious knowledge in a way that can ever encounter scientific knowledge and hold its own? So I'm exploring that and then just various other samples of when science and religion meet and what's the outcome there.
Okay. And when you say what is real and what is true, how do you define real and true versus how do you define reality versus truth with a capital T?
I'm always careful with truth with a capital T because it's very hard to say any statement is true beyond any shadow of a doubt. I think the only things that can possibly do that are just straight up contradictions, that there's no way that those can be true. But science isn't in the job of capital T truth, surprisingly. It tries approaching it, but it can never truly achieve it because we always have to believe we might do an experiment tomorrow and we have to scrap our best theories. Quantum mechanics in physics, amazing predictive power, but maybe it's ultimately wrong or incomplete in some way. After all, right now, some people are applying quantum field theory and are getting results for things in the universe that are off by literally 120 orders of magnitude. That's one with 120 zeros after it. When you're off that much, something's wrong. So science, though, we know it progresses. It does well. It keeps getting better and better every day. I mean, just a few centuries ago, we could barely understand motion. Nowadays, we understand motions of subatomic particles so well that now we can build iPhones. Science does that. And how does science ultimately work? It's all about basically hypothesis, testing, amplifying those results, rethinking about them, retooling, and getting something that better conforms to it, making new predictions, and continuously progressing and getting closer and closer to what we think is true and more reliable. So, in an important way, though, what I might call true or true belief is what has been the definition of truth from Plato, that something is a true thing if it's a justified true belief. That's when we have knowledge, justified true belief.
Well, that definitely aligns with your first book project on the start of Bethlehem, right? All these different interpretations and hypotheses of what the Star of Bethlehem was or if it's there. Now, to backtrack a little bit, can you define and make the distinction between what is real versus what is reality?
I think the best way I can put there is that reality consists of all the things that are real. So one would be the larger set. So squares and circles are all in the category of shapes. So reality is the collection of all things that are real. And what makes something real as opposed to imaginary? I would say probably the best thing is that it has some sort of external reference from beyond just my brain, that somebody else's brain can come along and also interact with it, can observe it, can have it bounce around in a way that is demonstrable to another person. So I know it's not just here, or it's not just a social construct. Real in that sense. You can still speak of social constructs as real, but of course not as like real physical objects. But I definitely wouldn't go the radical route that even apples are uh, constructs rather than actual things.
So now you've been talking a lot about numbers, shapes, reality, approaching what is true, right? But not approaching capital T. What about something that is so inexplicable, like something like affect, emotion? How do you describe that in your body of work? You know, when people read the Bible and where they supposedly they look up and they see the star of Bethlehem. How do you describe that? That is in an emotion.
Indeed, it's a really hard thing to use physics to explain emotions. This is much more the area of psychology, and certainly an area I wish I knew more about and knew how to research better. Unfortunately, I don't, at least don't yet have that sort of background. However, what I can at least do is this, is I can at least look at a person who feels this great affect when they read a sacred text, and I can try to see, okay, what was it there that made them have that emotional response, and can that be reproduced by something that I find, endearing, especially about the natural world. When somebody reads something and maybe it's about the Immaculate Conception for Mary, and to a Orthodox Catholic figure, um, this might be of extreme importance, the Mary, the Mother of God. But on the other hand, I want them to look up on a good night sky, look deep into another woman, the constellation of Andromeda, that was supposed to have been a princess, and deep in that constellation there's a fuzzy patch. It is the most distant object you can see with the naked eye. It's an entire galaxy of hundreds of billions of stars, with each star possibly having planets, with each planet having the possibility of having worlds with living and breathing and thinking creatures. That is so awesome to me. How do I make sure that someone can find that just as awesome as anything in any body of religious devotional work? That's the best I can approach the affect problem.
To bring it back, so you're almost as if saying that uh, how you feel is almost as if it's shaped by the things that surrounding you, by the reality that you perceive. So are you in a way suggesting that affect, emotion, it's something that is just as constructed and as artificial as an object you touch or see?
It's more constructed than any object we'll see because, in that case, affect is completely subjective. It's completely up here. It doesn't exist in the world itself, at least as best as I understand that. So, indeed, it is a completely constructed thing, which means fundamentally, if someone finds something of religious devotion to be awe inspiring, it requires a larger cultural context to make that so. Obviously, if I just go to a person and said, "Hey, there was this lady and she was without sin, and you have no concept of what sin is or why this should be important to anyone," you might as well just be listing off numbers from the phone book. And on the other hand, of course, with science, if I just give the distances to various stars, again, that can be just as boring. So there's definitely a cultural aspect and a constructed aspect to it, which of course begs the question, how might we reconstruct these things?
But obviously, you would agree with me that affect, emotion is a strong force in that, it propels people to do things, to not do things. No, it is not as frickled or as vulnerable as you're suggesting. Obviously, the power of the mind multiply is extremely powerful multiplier.
It's
How
definitely true.
how do you reconcile that with what you just said?
I don't see any necessary conflict with the idea that our emotions are so influenced by outside forces and that it's ultimately up here in our head. But um, once we have something up in our head, boy oh boy, can it just move forward with its own impetus in a way that um, evidence and argument can't stop and sometimes might just give a greater push. There's a fair bit of psychology that I know of that definitely backs that up. That if I go along and tell someone, hey, you're wrong about something, guess what? They believe it even more. So once you give someone that emotional push and they've got it locked in and that they feel that power, they will continue to generate that power for themselves, it seems. And boy, oh boy, does it take an amazing effort to have someone slow it down and possibly redirect.
Okay. So you just said if you tell somebody something, they're gonna believe it more and more.
Yeah, they might actually believe the opposite of what you want them to believe is true.
So my last question for you is why does the MIT Media Lab job is a good fit for you?
Because my project is ultimately about getting more of how the world works to the public. The Media Lab is all about trying to communicate interesting things to the world. I mean, that's what all of our media is about, somehow transmitting big, exciting things. What's the big, exciting thing I want to do? I want people to know about not just our scientific knowledge, I want them to know how we got there and how interesting that story can be. The vision I have is this: we have museums around the country, around the world, trying to, contain various artifacts and things like that, trying to show, hey, here's these amazing things we have. And there's a lot of effort in museums also try to tell a coherent story with these. The story I want to have is our story of how we got to the universe we have come to know. I have a vision of entering some room, and it's a room of universes, of like all the various constructs we've had, whether it's from mythology or more especially scientific creations of our solar system and our universes. Whether it's some of the most basic ones that the Babylonians or Aristotle had to the amazingly predictive model that Claudius Ptolemy had in the 2nd century AD. The models that were developed by the various medieval Arab astronomers. How about the efforts of Copernicus? How about the efforts of Tycho Brahe? Finally, that of Kepler and our